Alright, here's a quick exercise to get you used to permutations. So first, I'm going to write this in a way that lets me show you my favorite way of writing permutations. You go 1, 2, 3, 4, 5. And what does this mean? This means that this first parenthesis means alpha sends 1 to 2, it sends 2 to 3, and then it sends 3, because this is at the end of the parentheses, it sends 3 back to 1. And that's exactly what we see here. And so that's sort of, because these all go amongst themselves, that's sort of a cycle. So they just cycle through each other. And so that's gets its own parenthesis. And then the next parenthesis here is 4, 5, meaning it sends 4 to 5 and then 5. Swing it back around, 5 goes to 4. So that's what that means. And beta equals, and now here, we're not going to include the 1 because 1 goes to itself. So basically it would just be like a 1 in parentheses and then other stuff. But that's a little not useful. So we're just going to do the other things. 2 goes to 3, 3 goes to 4, 4 goes to 5. 5, there we go. And then we're not even going to write the 1 because it's just going to be understood that, oh, 1 does not appear here, so it must be sent to itself. So I like that. It uses like 50% of the number of lines needed to write than this other notation. Although the other one might be a little good for when you're first seeing it for the first time, but I like this. So if alpha equals this and beta equals this, then... Oh God. Oh no. Oh God. Go back. There we go. Okay. So what's alpha beta? Now remember this is a permutation, and so it goes from right to left. So when you send like a number through alpha beta, it first goes through beta and then goes through alpha. So it's kind of backwards. But anyways, let's think through this. So what happens to 1? Beta will send 1 to 1. So it's kind of like you start here, and then you go through beta, then you go through alpha. And so you start with 1. Beta will send it to 1, and alpha will send 1 to 2. So we start with 1, and 1 goes to 2. So what's next? 2. Beta sends 2 to 3, and then alpha sends 3 to 1. So 2 goes to 1, and so that's the end of the cycle, because 2 goes back around to 1. So I'll stop drawing this, but that's the basic idea of what's going on. So we have 1, 2, and then 3. Beta sends 3 to 4, alpha sends 4 to 5, so 3 goes to 5. And then 5 goes to 2, 2 goes to 3, so that goes to 3, and so that's a closed cycle. And so 4 is not included in here. So this is that. So beta alpha is, let's see here, 1 goes to 2, and then 2 goes to 3, so we have 1 to 3. 3 goes to 1, 1 goes to 1, so that's a closed cycle. So what happens to 2 now? So 2 goes to 3, and 3 goes to 4. So 2 goes to 4, 4 goes to 5, 5 goes to 2, so that's a closed cycle. And then, of course, 5 to 4, 4 to 5. So that's closed. It has to be closed here at the end, actually, because we've used up all the other ones. So there we go. And alpha inverse equals... Well, the nice thing about this notation is that you could just look backwards. So instead of going from 1 to 2 to 3, where will 1 go? 1 will go backwards. It will go instead of going this way, you go this way. And so 1, the first thing you do is you swing back around and you go to 3. And then you keep coming this way, and then you go to 2. And similarly, 4, you go all the way around and you end up at 5. So 4, 5. And so there we go. A nice short problem to begin this section. And we've done the proof.